exponential decay today as well. I'm going to give you a new formula today. It's called the compound interest formula, and it lays it all out here and what every little piece of it represents. Compound interest just means that instead of waiting till the end of the year to calculate your interest, you are calculating it at 4 different times. So you're getting interest on the interest from that first portion, because you're taking, like if interest was compounded quarterly, first of all, how many times a year would it be compounded if it was compounded quarterly? 4 times. 4 quarters in $1, right? Quarterly. 4 quarters in a year. As a school, in like school setup, right? You have 4 quarters. You don't. You have semesters. If it was compounded yearly, that's 1 time in a year. Biannually would be 2 times in a year, right? Bicycle, 2 wheels. Monthly, 12 times in a year. Quarterly, 4 times in a year. So there's all these different numbers that tell us when we would be compounding this interest that is coming in. But this is the formula for it, okay? P is your principal or your initial amount, the amount you start with. The annual interest rate is going to be this R. Notice R now is not, it's not just 1 plus R like it was before. Now it's 1 plus R divided by N, because we're dividing that interest rate by the number of times we compound it in a year. So if we're compounding monthly, we're taking the rate and we're dividing by 12. If we're compounding quarterly, we're taking the rate and we're dividing that rate by 4. So it depends what this N, the number of times that it's compounded, would be. And then T is always going to be our time in years for this one. So let me show you how this lays out. There is one just like this on your review, and there is one just like this on your quiz. The good news is, on the quiz, I told you exactly which formula to use for each problem. So we've done a lot of different formulas, right? We've done y equals a times b to the x. We've done y equals a times 1 plus r to the n power, or to the t power, or to the x power. Doesn't matter what you put there. Now we have this one. Sorry, this one. So there's a lot of different ways to set it up, but do you notice that they're really all the same type of formula? It's your original amount, something to do with the growth, or we'll learn again today, decay factor. And then this part of it, the exponent, is time related. Okay, so yes, they're different, but they're also very similar. I give you each formula at the top of the question that uses that formula. So you will not have to guess one bit which formula to use. I'll say, here's the formula. Tell me in this scenario what it would equal, okay? So that should be good. All right, so here's this one. Suppose that when your friend was born, your friend's parents deposited $2,000 in an account paying 4.5% interest compounded quarterly. And if I were you, when you do a problem like this, I would underline those numbers, because those are the things that come into play with how you're going to set this up. So if this is my equation, it says, what's the account balance after 18 years? I'm first just going to set up the equation, and then I'm going to figure it out after 18 years. So my equation is going to be A equals, what's going to take the place of P in this problem? What was your principal, your original amount, the initial amount that you started with? 2,000. So A equals 2,000 times 1 plus, and now here's where the division happens. How do you write 4.5% as a decimal?
0.045.
Yes, you're going to divide by 100. So 4.5, when you divide by 100, moves it over 2 decimal places. So 0.045 is going to be your R. What is your N right now? Yeah, Micah.
4.
You wouldn't ever what? I wouldn't turn it into a fraction, because especially like on this problem, it would be a fraction within a fraction then. So this is going to become a fraction right now. So if you turned 0.45 into a fraction, then you have a fraction as the numerator of a fraction, which is awkward. Okay, bottom number is what? 4. It's quarterly. Quarterly means 4. So you make this a 4. And then look here. It's to the nt power. What operation is happening between n and t? Multiplication. So your n is 4. What's your t? 18 years. We'll just plug it in right now. That's fine. Okay, here's where I need you to pull your calculator out and make sure you can plug it in, because a lot of people can get to this point and then they plug things in goofy and they get the wrong number. So get your calculator out and see if you can plug this in and get the right answer. Yes, sir. Yeah, the blue tape drawer has calculators in it. Just plug it in as 4 times 18. I mean, you could do it.
7647 point bunch of numbers.
I don't think so. What'd you get?
1, 4, 5, 6.
That's not what I got either. Is anyone getting $4,475.53? Nobody's getting, did I plug it in wrong? Hold on. Yeah, no. Okay. Nobody. I got it right. Did anyone get $4,475? Can I borrow one of your calculators? Can I borrow that, Shane? I want this guy. Are you using parentheses?
Yeah. I still don't think I got the right thing. Wait, what you guys? Are they supposed to be exploded?
Oh, I bet I know why.
Like 4,000. How are you getting 4,000?
Okay, I know why you guys are not getting what I'm getting, I think. Let me just double check that this... Yep, I know why. Okay, here's why. Your calculator is not as smart as mine. That's part of the problem. Here's what you have to make sure you do. If you're just going to plug it into your calculator, you have to put parentheses around this because your calculator thinks you're taking it to the 4th power and then multiplying that by 18, and we're not. We're taking it to the 4 times 18 power. So you need to put these parentheses in if you're just going to drop it all in as one thing. You could also piece it out. You could figure out what 0.045 divided by 4 is and add that to 1. You could figure out what 4 times 18 is. So you could go like this. 2,000, 1 plus 0.045 divided by 4 is this number. Okay, and then 4 times 18 is 72. So here's your other option. This is the same thing. I just calculated that and I calculated that. Either way, you should get $4,475.53. And don't forget to label it as money. Okay, this is money. Police. Syntax error? Okay. So then look at this second one here. It says, what if interest was compounded monthly? What changes?
So then it would be 12 instead of...
Only the force, only the n, okay? So you would go A equals, now let's see if you can plug this one in right. 1 plus 0.045 divided by what? 12. To what power? 12 times 18. So you have to put parentheses around 12 times 18 if you're going to do that. See if you can plug that in and tell me what you get. $4,489.01.
Yeah.
Yes. Okay, so what this should come out to is $4,489.01. Don't forget your dollar sign. We need to know we're talking about money here, okay?
Did you finish?
I got like a.
Wait, so we put parentheses?
You got a what?
Next to
I got.
If you need help with plugging that in and I didn't get to you yet, just let me know. Okay, I'll help you in a minute. We'll finish this and then I'll come back around and help out wherever help is needed. I'll help you. That calculator does it a little different. Okay, here's the only other thing. Yes. We talked about on Friday exponential growth. And do you remember what that formula looked like? I did it like this. Y equals A times 1 plus your rate to the x or to the t, whatever power we're doing, okay? Exponential decay is different. Remember on Friday, I said if we had grown by 5%, then we are 105% of what we started as. The same is true with decay, but in the other direction. So if I am 100% of me and I lose 5% of my weight, what percent of me am I now? 95%. So you're still taking that 1, but instead of adding the percent to it, you're subtracting the percent, okay? So this is going to be y equals A times 1 minus the rate to whatever power we're taking it to. So this is the only difference from how we did it on Friday. Now we're subtracting instead of adding, but it still has to be that you're using a 1 because it's 100% of what it started as and we're taking away, or with exponential growth, it's 100% of what you started with and we're adding to it, okay? So take a look at this. Exponential decay is on its way down. So this is a graph of what exponential decay is gonna look like. It's still this a times b to the x, but we're subtracting our b becomes 1 minus the rate. Okay, so we just put in 1 minus r instead of 1 plus r for that b. So let me show you how this goes, and we'll lay it out together. On the quiz and on the test, I'm going to give you this. Y equals a times 1 minus r to the x or to the t to some power. Okay, so we're just going to do it with this formula instead. Look at what this says. The kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude, the pressure decreases about 11.5%. What's the approximate pressure at an altitude of 3,000 meters? Here's my first question. If it changes every 1,000 meters, how many cycles are we doing in this problem? 3, because it's going to 3,000 meters. So if every 1,000 is where the decrease happens, then our t or our x, our time, in this problem is going to be 3. Does that make sense? Every 1,000, we're decreasing. So t or x is going to be 3. So if we're starting this problem at sea level, what is our original amount? How many kilopascals are we starting at? 101. It says it's 101 kilopascals at sea level. So we're going to say y equals, so A is 101. And then this is 1 minus your rate. This is not a money thing where we're compounding monthly or quarterly or whatever. We're not dividing by n anymore. We're just using this equation now. What is your rate? 11.5%, how do you write that? 0.115. So you take 11.5% and you divide by 100. 0.115 to the x power or to the t power. So this would be your equation. If you want to simplify that equation, you could go 1 minus 0.115, and you could write it like this. Y equals 101 times, this would be 0.885. That kind of helps you to see that it's decay, right? It's less than 1. So I like to write it like that, but you don't have to. If you leave it like this, it's not wrong. The question is, if we're trying to figure it out at an altitude of 3,000 meters, and we said every 1,000 it's changing, then we're plugging x equals what? 3 into this equation. So your solution is going to be y equals 101 times 0.885 to the third power. Plug that in and see what you get.
Wait, I'm confused on how you got the third.
The 3?
Yeah.
So it says for every 1,000 meter increase in altitude, the pressure decreases. So our decay is happening every 1,000 meters. And it says, what would that be at 3,000 meters then? So that's 1,000 meters 3 times. So your amount, your time, if you will, it's happening 3 times at 3,000 meters. Yeah, Micah. What'd you get? Yeah, so your solution is 70 what? Kilopascals, right? So I rounded, but it was pretty close to 70, 70.00856, okay? So it's about 70 kilopascals at 3,000 meters.
If it's like that, it's okay, we just put about, or do you want us to write the number if we don't round?
If it's a number like this, you're gonna have to round. So just say about, or you can do the little squiggles mean about approximately. Yeah. That's really all we're doing today. The only difference is we're subtracting from 1 instead of adding to 1. And there's this new formula that comes into play with compound interest. So just pay attention to what the question is asking you. If it's talking about compound interest, it should be this formula. If it's talking about exponential decay or exponential growth, because we know that one too, 1 plus or 1 minus the rate.